All right, welcome. This is the Module 2 Review Packet Solutions. Here I'm going to cover Part 5 all the way to Part 4, which is basically the second page. Okay, Part 5. It's a multiple choice question. A forest fire starts, and the fire chief noticed that the fire area starts with only 20 acres. As time goes on, the fire grows by a factor of 2 every hour. Assuming the relationship between the hours and the acres of fire are continuous, which of the following function describes the relationship? There are certain key things that I highlighted. I highlighted that the fire area starts with 20 acres and it grows by a factor of 2 each time. So f of 0 is 20 and my carbon difference here is 2 because it's growing by a constant rate of 2 every hour. It's not a common ratio, okay? It's growing by 2 each time. So it's the first one is 20, the second one would be 22, and the third one is 23. So here it should be D, right? Because it's in y equals mx plus b. Okay, y equals 2x plus 20 would describe this scenario. Number 2, a newborn cow will gaze and eat around 2 acres of grass initially. As time goes by, the cow eats 2,000 more acres of grass as time goes by. This is actually a real life number. It takes a lot of acres of grass and water to actually make a cow. Okay, so that's the reason why beef is expensive. All right, so you're going to assume the relationship between the time and the acres of grass eaten are continuous. All right, so certain things that I highlighted here is the 2 acres of grass initially, okay, and the 200% of acres of time goes by. F of 0 equals to 2. The R here is 20. How am I getting 20? 2,000% is just R being 20. Okay, notice for 100% it's 1. For 200% it would be 2, right? So for 2000% it would be 20. That's how I know my R equals to 20. And A of 2 times 20 to the power x is the 0 term explicit, which is the only correct one for this one. Okay. Part 6. A relationship is shown between the number of students doing homework and the number of problems they are getting done. Okay, not a sequence with a constant rate. That is wrong. It seems like the problems done are increasing by 4 for every single one student. So the sequence, it's a sequence, but it's not arithmetic or geometric. I don't think so. It looks like it's arithmetic because it's going up by 4 problems per every single one student. So the answer would be D. The problem done is increasing by 4 for every single student. So it is a sequence and it is a type of arithmetic sequence because it is increasing by a constant rate. 7. Okay. 7 is a multiple choice question. It says Mrs. Owens owns a house in Fontana. The real estate company determines the value of Mrs. Owens' house every year. The exponential function s of t equals to 400 times 105 to the power t models the relationship between the value h in thousands of dollars of the house and the number of years t since Miss Owen owned the house. Which statement correctly interprets this model? A. Well, I highlighted a couple of things. First of all, I know that my 0 term, it's the 0 term exponent. The 0 term here would be 400, right? Because that's the exponential function that was given. And I know it is increasing by 5% each year, or the R becoming 1.05 based on the information given. Okay, so it would be B. The value of the house increased by 5% every single year because that's what we got from looking at the common ratio. Okay, it wouldn't be A. It's not increasing by 1.05% every year. No. Okay, the value of the house is increasing by 1,005. No. The value of the house is increasing by 500 every single time. No. The only one that makes sense here would be B. Part 7, multiple choice. Mr. Owens is the husband of Miss Owens from number 1. He's going through a midlife crisis and wants to spend the money he got from the value of his house increasing by, so he decides to get a reverse mortgage. The reverse mortgage allows you to get money basically for your house. So he spends the extra money on a motorcycle and the exponential function mt equals to 12,000, times 0.85 to the power of t minus 1. Model the value of the Mohr cycle over time. Please understand, this is not the zero term. This is the first term explicit. Okay? It is the first term. It is the first term explicit. The reason why it's called the first term is because it's to the power t minus 1. Okay, so f of 1 equals to 12,000, and f of 0, if you ever want the f's of 0, it is the initial, the first, because remember how we're going to the next term in the exponential function, we multiply it by r. So to go backwards, we divide by r. So that's what I did there. Okay, so the R here is 0.85, or decreasing by 15%. The reason why I got the first, the zero term, is to answer one of the questions. So is the value of the Mohr cycle decreasing at, by 85% each year? No. Okay, so Mr. Owens bought the Mohr cycle for 14,118. That is correct. Is the value of the Mohr cycle decreasing by 1,800? No, because it is exponential. So the way it's decreasing is changing over time. And the value of the Mohr cycle is 8,670. That is correct. Okay, so it is the second one and the fourth one that is correct. Part 8. No, wait, hold on. Am I only covering part 7? Yeah, part 8's on the next one.